Good evening, dear students. I am very happy to introduce today's topic is IIR filter realization. IIR means infinite impulse response filter. The realization means it is a practical implementation of filters. Theoretically, what we studied in the book or by calculations, etc. But real implementation or usages from practical filters. How practically implemented the IIR filters in either DSP processors or computer systems. Both are useful for implementing filters. Only 3 elements are required for implementing IIR filters. First, I list the 3 elements which is useful for implementing the filters. One is order. Because 2 values are coming means addition is necessary in filter operation, and another one is multiplication or multiplier. So, multiplier also multiply the 2 values. So, we are doing multiplication as well as addition simultaneously, so it is called as a convolution. The filter is used for convolution. So, the operations, 2 important operations are addition and multiplication. It can be done by means of order and multiplier. So, third one is delay element. Delay elements are nothing but memory locations. Memory locations are used to store the past values. Only the present values in the memory location. Suppose the past values are necessary because of our calculation, we need present value of input, past value of input as well as past value of output. So, past values of input and output needs memory locations to store it. Then only we taken it for our current time calculation, especially y of n. Y of n is the current output at time n. So, for that calculations we need the previous values of output and previous values of input. It should be stored in the memory location. So, only these 3 elements are enough. We know that analog filters implementation we need R, L, C. These are the electronics components which are useful for implementation of analog filter. Analog filter is also having a 4 types: low pass filter, high pass filter, band pass filter and band stop filter, but the different values of R, L, C is needed. It is very tough because I want to change from high pass filter to low pass filter means my entire design should be changed, and also the values of R, L, C is changed. So, R, L, C is costly things. So, we have to every time we have to purchase R, L, C for the designing of new filters. For that reason only we are going for digital filters. For the digital filters we no need to purchase any components, only computer is enough or DSP processor is enough. So, you may design either high pass, low pass or band pass, band stop with the help of digital filters, and also any range. Any range also design, that is you may design for kilohertz or you may design for megahertz or you may design for gigahertz, even terahertz. For any design, just you are changing the software. Just you write the software and change the contents, you may easily change into low pass filter into high pass filter. Just to change the commands, that's all, right? As like analog filter, we have to analog filter means we have to change R, L, C physically. It cannot be possible in every time because all are cost oriented. Nobody is buying frequently. So, we go for digital filter. So, for the digital filter, we know that our computer is very much specialized in addition, multiplication as well as computers having lot of memory. These 3 things are enough for your implementation. So, now our aim is we have to take one problem, specific problem, and how it can be implemented practically by using four methods. One is direct from one realization, direct from two, next one is direct from two realization, and third one is cascade realization, and fourth one is parallel realization, right? So we have to see one by one with the same problem, right? Okay. Dear students, please see the board. The board having a single problem, only one problem, but the contents are more. Obtain the direct form 1 realization, direct form 2 realization, cascade and parallel realization of the following system. System means that is having an input x of n, that is having an output y of n, and with the impulse response h of n. So x of n is nothing but your speech signal. Your speech signal is x of n. Okay, right? H of n is nothing but your cell phone, right? Okay, it is having a filter coefficients. So your speech is convolved with the filter coefficients and it is go outside, right? So that is called as output response is y of n. Okay, based on that we formulated the equation. The equation is like that: y of n is equal to minus 0.1 y of n minus 1 plus 0.2 y of n minus 2 plus 3 into x of n plus 3.6 into x of n minus 1 plus 0.6 into x of n minus 2. Then how we have to proceed or to solve the direct form 1 realization? First we have to discuss about direct form 1. Okay. For this, now you take Z transform on both sides. Take Z transform. So just you take Z transform on the above given equation, then you write that y of n is converted into y of capital Y of Z. So dear students, here you listen that small y means it is in time domain, capital Y means it is in frequency domain. So n is time domain, Z is in frequency domain. So you represent your things very correctly. Small letter and capital letter both is having a different interpretations. Okay. So y of Z minus 0.1. Okay. Y of n minus 1. What is the Z transform of y of n minus 1? Here it is having one delay. One delay is represented as Z power minus 1 into y of Z. So y of n minus 1 Z transform is Z power minus 1 into y of Z. It is studied in our earlier classes in signals and system, or in mathematics also you may study it. Then next term, constant is not a problem. Y of n minus 2. The Z transform for y of n minus 2 is Z power minus 2 into 2 delay into y of Z. Okay. Three is a constant. X of n is having an Z transform of x of Z. Similarly, x of n minus 1 Z transform is Z power minus 1 into x of Z plus 0.6 Z power minus 2 into x of Z. Right? I think everyone is clearly understand that by using the delay property y of n minus k. General form is y of n minus k, we take Z transform is Z power minus k into y of Z. So same thing we are using and wrote the equation, right? Next our step is just it is simplification. So y of Z is you take on one side and x of Z would be in another side. So y of Z, I took the now I want to take the two terms into this left hand side, plus 0.1 Z inverse into y of Z minus 0.2 into Z power minus 2 into y of Z. This is equal to 3x of Z plus 3.6 Z inverse into x of Z plus 0.6 Z power minus 2 into x of Z. So now I want to take y of Z as a common factor in left hand side and x of Z is common for right hand side, because we want to construct the filter. So filter means it is having a transfer function h of z. H of z is equal to y of z divided by x of z. So, y of z divided by x of z means we formulated the transfer function of the filter. So, for that aim, now I take y of z as a common for this equation. Fine. Here you take x of z as a common factor. The remaining thing is like that. Then as usual I told h of z is equal to y of z divided by x of z. Y of z divided by x of z. Y of z is here, x of z is here. So, I took x of z into downside. The remaining thing is 3 plus 3.6 z power minus 1 plus 0.6 into z power minus 2 divided by this y of z. The remaining thing is got into the next slide, it is going to division part. So, 1 plus or denominator part, it is got into denominator side. So, you correctly put it, just as a cross multiplication like that. So, x of z come into denominator of this side, and 1 plus 0.1 z power minus 1 minus 0.2 z power minus 2 is come into the denominator of your right hand side, right. So, this is called as h of z. Now, this is the important relation. Now, you see that here clearly you understand order is there and multiplier 3.6 is multiplied by z power minus 1, 0.6 is multiplied by z power minus 2. Okay. So, order is there, multiplier is there, z power minus 1, z power minus 2 are the delay elements. So, only order, multiplier and delay element is enough for constructing the filter. Now, we go for the practical implementation from this h of z. So, how we have to construct the direct form 1. I want to draw the direct form 1 structure, right. So, drawing is very easy. Please see that. So, this type of structure is available in the computer or DSP processor for the practical implementation. So, x of n, your speech signal is coming. Here the constants are there. From your constants, these constants are called as filter coefficients. It is multiplied with your speech signal is multiplied with these filter coefficients. The convolution is happen place. Then after the convolution, the output sequences go into the AR media. Then AR media, it is go to the receiver side. The receiver side means your intended speaker is available. Then it is again it is convoluted. Then you get a original speech signal x of n at the receiver side. Okay. So, this is the necessary things. Please next slide we take this transfer function and we have to draw that.